Welcome to Stimulus Discrimination, a foundational concept that will sharpen your ability to analyze how behavior changes across different situations. In this segment, we'll explore the core definition tied to BCBA task B.13, clarifying how an organism learns to respond in the presence of one stimulus but not another. You'll see how this differs from stimulus generalization and maintenance, and we'll break down the key components of discrimination training, including the critical role of the discriminative stimulus and the three-term contingency. We'll also distinguish stimulus discrimination from motivating operations, which alter the value of a reinforcer rather than signaling its availability. Finally, we'll cover simple and conditional discrimination procedures from task G.6 and contrast B.13 with B.14 on generalization. Mastering these distinctions is essential for the exam, as they directly impact how you design effective behavior change interventions and interpret functional relations in applied settings. Stimulus discrimination is a foundational concept tied directly to BCBA task B.13, and it's essential to understand how differential reinforcement history shapes behavior. When a response is reinforced in the presence of one stimulus, the discriminative stimulus, or SD, but not in the presence of another, the stimulus delta, or S delta, the learner begins to respond selectively. For example, a child says ball only when a ball is present, not when a car is present, because only the ball has been paired with reinforcement for that vocalization. This process is what establishes stimulus control, meaning the SD reliably evokes the behavior while the S delta suppresses it. On the exam, you'll need to distinguish this from stimulus generalization, where similar stimuli evoke the same response. Remember, discrimination is about responding differently to distinct stimuli based on their reinforcement histories. Mastering this distinction helps you analyze why certain antecedents control behavior in applied settings, which is critical for designing effective interventions and interpreting client responding. On this slide, we distinguish three critical concepts for stimulus control on the BCBA exam. Stimulus discrimination means a behavior occurs only in the presence of the SD because reinforcement is delivered exclusively when that discriminative stimulus is present, while the S delta signals extinction for that response, like saying red, only when shown a red card, not a blue one. Stimulus generalization, in contrast, occurs when behavior happens in the presence of stimuli similar to the SD due to a shared reinforcement history. Teaching across multiple exemplars strengthens this. Response maintenance is different. It's about behavior continuing after intervention is reduced, relying on schedule thinning and natural reinforcers, not directly on antecedent stimulus control. For the exam, remember that discrimination narrows control, generalization broadens it, and maintenance focuses on durability. You'll need to identify which process is at work in scenario-based questions, especially when evaluating intervention outcomes or planning for generalization across settings. Stimulus discrimination training is a foundational procedure you'll need to master for the BCBA exam, and this slide breaks down its four key components. First, you present the discriminative stimulus, or SD, like a red card, which signals that a specific response will now produce reinforcement. When the learner emits that target response in the presence of the SD, you deliver reinforcement immediately. This immediacy is critical because it strengthens the connection between the SD and the reinforced behavior. Next, you present the stimulus delta, or S delta, such as a blue card, which signals that the same response will not be reinforced. If the learner responds in the presence of the S delta, you withhold reinforcement, essentially placing that response on extinction. This contrast, reinforcement for SD responses, extinction for S delta responses, teaches the learner to discriminate between stimuli. On the exam, you might be asked to identify whether a procedure correctly implements these components or to distinguish discrimination training from generalization. Understanding how the SD and S delta control responding is essential for designing effective teaching programs. On this slide, we distinguish stimulus discrimination from motivating operations, a key comparison for the BCBA exam. Stimulus discrimination's primary function is to evoke behavior because it signals reinforcement availability based on a history of differential reinforcement with an SD and S delta. In contrast, motivating operations alter the reinforcing effectiveness of a stimulus and evoke behavior through deprivation, satiation, or other environmental variables. For example, saying cookie only when a cookie is visible is attacked under stimulus control of the SD, while being food deprived increases the value of a cookie as a reinforcer, making it an MO. The effect on behavior. Stimulus discrimination increases response probability only in the presence of the SD, whereas MOs alter the current frequency of all behaviors reinforced by that stimulus. On the exam, this relates to task list items B.13 and B.12 for stimulus discrimination and B.16 and B.17 for motivating operations. So understanding how these mechanisms differ in function and effect is essential for scenario-based questions. On the BCBA exam, you must distinguish between simple and conditional discrimination procedures, as they form the foundation of stimulus control. In simple discrimination, a single antecedent stimulus, like the spoken word red, directly controls a specific response, such as touching a red square. Conditional discrimination is more complex. The function of one stimulus depends on another, as in matching to sample MTS. Here, a sample stimulus sets the occasion for selecting a matching comparison. Two MTS types are critical for the exam. Identity MTS, where sample and correct comparison are physically identical, e.g., matching a red card to another red card. And arbitrary MTS, where the relation is learned through training, not physical similarity, e.g., matching the word dog to a picture of a dog. Errorless discrimination training uses prompts to ensure correct responses initially, then systematically fades them to prevent errors and build strong, efficient stimulus control. Understanding these procedures will help you analyze how antecedents guide behavior and design effective teaching interventions. Stimulus discrimination and stimulus generalization represent two sides of the same coin in how behavior comes under stimulus control, and the BCBA exam will ask you to distinguish between them, specifically under tasks B.13 and B.14. With discrimination, you respond differently to distinct stimuli because your reinforcement history taught you that responding to the SD, the red light, pays off, while responding to the S-delta, the green light, leads to extinction. The outcome is narrow, precise control, like only saying stop when the light is red. Generalization, by contrast, occurs when you respond similarly to stimuli that share common physical features. For example, calling a sedan, SUV, and truck all car, because reinforcement for one stimulus extends to similar ones, producing broad control. Clinically, discrimination helps you teach a learner to identify a specific color or letter, while generalization ensures that skill transfers across different people, settings, and materials. On the exam, expect to identify which process is at work in a given scenario, remembering that discrimination narrows behavior, generalization broadens it. Establishing stimulus control through discrimination training is a foundational skill on the BCBA exam, and the process follows a clear, systematic sequence. First, you identify the target SD. The specific stimulus that signals reinforcement is available, and the S-delta, which signals extinction for that behavior. When you present the SD, you wait for the correct response and immediately deliver a reinforcer, strengthening the behavior in that context. Then, when you present the S-delta, you withhold reinforcement entirely, even if the response occurs. This teaches the learner that the behavior is not effective under those conditions. You then alternate SD and S-delta trials randomly to prevent pattern learning, and you initially use prompts, such as pointing or modeling, to guide correct responding, systematically fading those prompts so the learner responds independently to the SD alone. On the exam, expect questions about how differential reinforcement across these two stimulus conditions builds discrimination, and why prompt fading is essential to avoid prompt dependency. Master this sequence to explain how learners come to respond appropriately in one context but not another. When teaching stimulus discrimination, the BCBA exam expects you to know how to systematically transfer stimulus control from prompts to the natural SD. Most Elise prompting starts with the most intrusive prompt, like full physical guidance, then fades across trials. Ideal for learners who need high initial support, such as guiding a child's hand to touch the correct picture. Least to most prompting begins with the least intrusive prompt, like a verbal cue, and increases only after an error, promoting independence from the start. For example, saying, point to red, then gesturing if needed. Time delay, covered under G.8, involves presenting the SD and waiting a fixed interval before prompting, starting with a 0-second delay and gradually increasing the weight. This procedure directly transfers control to the natural SD, as when you show a card and wait 2 seconds before pointing. On the exam, you must match these procedures to client needs, recognizing that time delay is especially effective for building fluent discrimination without prompt dependency. On this slide, we're breaking down how stimulus discrimination operates across different verbal operants, a key distinction for the BCBA exam under B.19 and B.20. For attacked, the discriminative stimulus is the nonverbal object or event itself, like seeing a dog and saying dog. The environment directly controls the response. In contrast, Amand is evoked by a motivating operation, not an SD. Thirst functions as an MO that makes water reinforcing, so the response is about accessing that reinforcer. This distinction is critical because it changes how we analyze and intervene. With TACs, we manipulate the nonverbal environment. With MANs, we target the MO. Multiple control, covered under B.20, reminds us that real-world verbal behavior is rarely simple. Often, both SDs and MOs converge, like when answering a question involves both the verbal SD and the MO to provide information. Finally, intraverbals rely on a verbal SD without point-to-point correspondence, like, what's 2 plus 2? Evoking for. On the exam, you'll need to identify which antecedent controls which operant. When designing discrimination training programs, which is assessed under tasks G.6 and H.2 on the BCBA exam, you must systematically select stimuli that are meaningful to the learner, ensuring the SD and S delta are relevant to their natural environment and preferences. Choosing an appropriate prompting strategy, such as errorless teaching for novice learners or most at least for more complex discriminations, reduces errors and builds accurate stimulus control. Trials should be arranged randomly to prevent the learner from relying on a predictable pattern rather than the actual stimulus features. Immediate, high-quality reinforcement for correct responses to the SD strengthens the discrimination, while systematic error correction, like modeling the correct response and repeating the trial, prevents the learner from practicing mistakes. Finally, you must collect trial-by-trial data and make database decisions to adjust the program as needed, a skill tied to task H.7. The exam will expect you to apply these steps fluidly, recognizing that discrimination training is not just about teaching a response, but about ensuring that response reliably occurs in the presence of the SD and not the S delta. On this slide, we're distinguishing stimulus discrimination from response generalization, two concepts that often appear together on the exam but serve very different functions. Stimulus discrimination focuses on antecedent stimuli. You learn to respond differently to different stimuli based on your reinforcement history. For example, saying cat only when a cat is present, not a dog. Here, reinforcement has been delivered for a specific response to a specific stimulus, which teaches precise, context-specific behavior. In contrast, response generalization focuses on the response side. You emit different but functionally equivalent responses, like using open, unlock, or turn the knob to open a door. Reinforcement for one response increases the likelihood of other similar responses, promoting flexibility and problem-solving in novel situations. On the BCBA exam, you'll need to identify examples of stimulus discrimination, B.13, and distinguish it from response generalization, B.14. Clinically, stimulus discrimination builds accuracy, while response generalization builds adaptability. Both are essential for effective behavior change. When building stimulus control, BCBA candidates must recognize that discrimination training often breaks down due to common procedural errors. Inconsistent reinforcement of the SD weakens the contingency, so initially use continuous reinforcement to establish control before thinning the schedule. Accidental reinforcement of the S delta, even occasionally, creates faulty stimulus control. Ensure extinction is applied consistently to every S delta response. If the SD and S delta are too similar, discrimination becomes difficult. Start with highly distinct stimuli and gradually increase similarity. Insufficient trial repetition prevents the learner from acquiring the discrimination, so plan multiple practice opportunities. Prompt dependency is a major pitfall. If prompts are not systematically fated, the prompt, not the SD, controls behavior. Finally, without probe trials that present the SD and S delta without prompts, you cannot verify true stimulus control. On the BCBA exam, expect questions that ask you to identify which error is occurring in a scenario, such as recognizing that a learner only responds when a verbal prompt is present, indicating prompt dependency rather than genuine discrimination. As we close, remember that stimulus discrimination is the bedrock of efficient behavior. It's the process that ensures a learner responds only when the right signal is present, not to every similar cue. You've seen how it differs from generalization, which broadens responding, and from maintenance, which preserves it over time. The key is that discrimination training establishes stimulus control through differential reinforcement, where a specific SD sets the occasion for a reinforced response, while other stimuli lead to extinction. This ties directly to conditional discriminations, prompting strategies, and even verbal behavior, where tax and mands rely on precise antecedent control. Avoid common errors like weak stimulus salience or inconsistent reinforcement, and always design programs that systematically transfer stimulus control. On the exam, expect questions that ask you to identify the SD, the reinforcer, and a non-reinforced stimuli in a given scenario. You've mastered the concepts. Now trust your analysis, practice with real-world examples, and walk into that test knowing you can discriminate the critical from the clutter.